Okay, carrying on with applying multiple transformations to a single function, just to remind you the question that we've been posed is given y is equal to f of x, graph y is equal to negative f of 2x plus 2 plus 3. And there are three different methods that we're going to look at for doing this. The first one, which we'll look at in this video, is working right on the graph. And then in subsequent videos, I'll show you what I call the arrow method for each point, and also a method that involves making a transformed table of values. So going back to the problem, remember that we said with any of the methods, the important things to do first are to factor what's inside the bracket. So the immediate coefficient of x is equal to 1. So in this case, we needed to common factor out the 2, as we saw in the last video. And then we also need to list all the different transformations. So I'm just going to fill those in on this slide here. Okay, now that we've got those, if we wanted to work right on the graph, what we would do is take each of the major points here on this graph, or if you were working from a different parent function from that one, you choose a few important points, and we want to take them through all of the different transformations, keeping in mind that we need to do reflections and stretches before we do translations, and that it doesn't matter if we do vertical reflections and stretches and then horizontal reflections and stretches, or if we do all the vertical stuff first and then all the horizontal stuff first, as long as we do the stretches and reflections before the translations. So in this case, let's take this one point here at the end, which is negative 4, 0. So just working on the graph, we're not even going to look at the table of values. We know, though, that from the blue writing at the bottom right, we need to vertically reflect it. So vertically reflecting it's not going to do anything because it's already on the x-axis. Then we're going to horizontally stretch it by a factor of a half. That means we're going to have to move it this way towards the x-axis to half of its original value. So it's going to end up there. Then, once we've done that, we've now done all of the reflections and the stretches. So now we can just do the translations. And in fact, the order that we've written them in is a fine order to do all of them in, because it's got our reflections and stretches first and then our translations. So we'll just carry on going. So now we need to do a horizontal translation left by 1. So now we ended up over here. And then a vertical translation up 3. And in fact, the arrow that I put is going to point right to where that dot is. So this point here has ended up here. We vertically reflected it, which didn't do anything. Horizontal stretch factor half. Moved left 1 and then up 3. If we carry on, vertically reflecting this point down here gets us up to here. Then horizontally stretching it in half gets us over there. Moving left 1 moves back over to here. And then vertically translating up 3 gets us up there. So we've moved to there. The point at the origin here, vertically reflecting does nothing, horizontally stretching it does nothing, moving it left 1 and up 3 is going to get us to there. Now this point here, vertically reflecting it brings us down to there, horizontally stretching it by a factor of a half brings us to there, left 1 there, and up 3 brings us to here. And the last one, vertically reflecting it is not going to change it. Horizontal stretch factor of a half brings it to here. Horizontal translation left 1 and then up 3 brings us to there. Now we connect them in the same order that they were connected before, which is going to look a bit like that. And that would be our drawing of our new function. Don't get thrown off by the little arrow on the left. So that would be our transformed function. This is now the graph of negative f of 2x plus 2 plus 3. In the next video, we'll look at another method of transforming the function to get this end picture.